Okay, and let me pull up a whiteboard. Jamboard. Can you all see this whiteboard? Okay. No or yes?
No, I can't see it.
No, we don't. It's saying we don't have access.
Okay. Oh, that's lame. Like it gave you a link and you couldn't click on it, or when you clicked on it, it said you don't have access to this board.
It let you request access, but then it said access denied, and we'll send you an email when you're granted access.
Okay, hold on.
For me, at least.
Yeah. Okay. So I'm gonna send a mess. Yeah. Okay. I guess I did the whiteboard on Zoom last time. So there's a new link, and I guess that's just gonna let you view it sort of outside of the call, I guess. But maybe I guess I could share my screen. I wonder if it'll just let me do that. Yeah, I'll just do that. I think that's maybe what I did last time. Okay, so you guys can see this now though, right?
Yes.
Okay, cool. Okay, so for this module, we are learning about servers and databases. So how to use databases and how to program logic that makes a program a server. So who knows what a server is? Who wants to hop in? I think I've said it before a little bit, but does anybody want to be brave and say something about what they think a server is?
A computer program or device that provides access to a central resource or other functionality for clients.
Thank you, Sherry. Was this a wiki? What was this? Did you know that?
No, I Googled it.
Well, fair enough. I love that you did that. Yes, that's the definition. And have we dealt with a server before in this class so far? Does anybody know if we've ever talked with a server in this class? In this this whole in the last. Do what? Go ahead.
Is it Node?
Yes. So Node is the backend runtime for JavaScript. It's like how you run JavaScript on a server actually. So or on or just on your computer. It's how you run JavaScript outside of the browser, which if it's outside of the browser, then it's pretty much a server, though it can also just be your laptop. But we've talked with the server before. We talked with the server, and I think we use a different term typically, but we've talked with the server in the last module. Does anybody remember which one we were talking to? I feel like my questions are either just really bad, and they're not leading enough, and then if they're really bad, I try to correct and I overcorrect and give the answer. But the weather API that we use, so we had our React app, and that React app, we made the front end for it, and it would do fetch. Remember fetch? It would talk to the weather API. And when the term API, you're going to hear used all the freaking time, and it's going to mean something different every time. But you'll hear API often used as a server that's going to give you back something when you talk to it. And typically, it's giving you back JSON data. So it's giving you back like an object or an array of objects for you to do something with in your application. So the weather API, the fake weather, or not the fake, it was like real weather, is a running server that is waiting for you to talk to it, and it gives you back data whenever you hit certain URLs. So we had done a little bit of whiteboarding before, but we had a shape or something. Shape. So we had talked about, hey, there's like servers out there that are just like waiting for you to talk to them. And we have always sort of mainly used the browser or like a client. Is like the main area that we've been programming mainly. It's like we've been doing it in the browser. And we have made requests with Fetch to a server. And does anybody know like what type of request, like what protocol or how we communicate with stuff over the internet? Does anybody know what that's called?
Isn't it like the HTTP?
That's right. Yeah, so we make HTTP requests. And now I'm getting into freeform mode and everyone's gonna freak out about how bad this is gonna be. But yeah, we make HTTP requests from our browser, typically with the Fetch API. So that'll be like, and it'll be to a specific URL. So it'll be what we did before was like https://weather something.com. I can't remember exactly what it was. I want to make this text smaller. It was something like https://api.weather.com or something like that. And then / like forecast. And then we had like, here's our API key as a query parameter. Right. So whenever we wanted to have our browser get data from something, we would make an HTTP request, which is just like how you communicate over the internet. We'd send that request to a specific server. So this server is listening at this URL, and then it receives that request, and it has to like figure out what you want. So it looks at the URL, it looks at various things that we're going to learn about today that make up a request, and it's like, oh, this is what you want, so I'm going to go get that for you. And we haven't talked about this, but like when it was giving us the weather information, the real-time weather information, all of that is stored in a database. So like they're collecting weather data as it's happening, there's instruments or whatever they have, or they're getting it from the National Weather Service or whatever, right? So they're like collecting all this information and then they're storing it in a database. So there's some sort of job out there in this weather example that's like collecting information and putting it in the database for people to be able to see. And it's stored in a particular format. So there's a bunch of different database types out there. And we're going to learn one particular type that's quite popular. But just know that there's different types of databases. You'll hear SQL database, NoSQL database. And then there's just like, that's like the highest kind of category split. And then there's just like hundreds within each of those different types of databases. But they all do the same thing, which is they store information, they persist it. So it's like literally like kind of like a hard drive or like a solid state drive, just full of data. And so they make it easy for you to put data somewhere to store it, for you to update it. And then they also are really good at helping you retrieve it really quickly. So they provide a way for you to query what you're looking for. So you can ask for like, hey, give me the data by this ID, or give me the data where some condition is met. Like, give me all the people with a birthday greater than 18, or like various things like that. So any sort of query you can think of, the database will provide a language and a way for you to get the data that you want. So all the weather data is in this database. So, but you don't ever directly communicate with the database. So in this architecture here, where you've got a browser, you always talk to the server, and then the server handles talking to the database for you and getting what data you're looking for, and then giving that back. So in our like full example of what we had built with our weather app, we had the browser that would make a request through HTTP for the forecast data to the server. That server then was like, okay, I think I know what you want. I'm going to look for that in the database. I'm going to get that information back from the database, and then I'm going to give it back to you in JSON format. So I'm going to give you that object, you know, that had like the forecast key, and then the forecast days array of forecast information. So any questions so far? Okay, sweet. It's an amazing drawing. Everyone's just getting it so well. So what other stuff can you guys think of that a server might have to do? So it doesn't just like get a request and then just hand you back data. Like what are some other things you guys can think of that a server might be responsible for? Maybe you don't have to answer, just think for a second. Like, what's some other stuff that you could think of that like happens that this server thing that you're learning about might have to be responsible for, or might have to do? So just think about that for a second.
Stream video?
Yes. Yeah, so they, like in the Netflix example, like they are not just like handing back just JSON data. They're like gonna stream video to you. Yeah. So a few other things that a server does is it handles like permissions. So if you think about that, the weather API, like we had to get a token, and that token uniquely identified who we were. And so the server will often do like permissioning, and like it has to figure out, you know, who are you, and then it has to like authorize you to do certain things. So in the case where we had like not really paid them quite yet, we had like the free API key, it would get the request, and think about this, like there's nothing in the request that says only give me back, because remember we were only ever getting back 3 days, even though we'd asked for like 10. So if you think about the URL in that scenario, the URL was, you know, forecast API key query is 73106, and then days is 10. And the server gets that, and it's like, hey, they want 10 days, and then they have to go, well, who is this? So they take the token, and then they see, okay, who is this person with this token? Oh, it's this person, and oh, hey, they don't pay us. So like they ask for 10 days, but only give them 3. So that's like logic that is in the server. Like whenever you make the request and that server is processing the request, that's some of the logic that may be written, which is like, hey, you know, like we can't give certain data, so we should maybe strip it out. Like, so it's all in the database. We can get it from the database, but we shouldn't give back to the client all of that data because they're not paying for it. So that's one thing they have to do. Some other stuff that you'll see happen with the server is just sort of like stringing together a bunch of other business logic or business processes that you have to do. So when you sign up for some website or for some web app, like you'll make a request to sign up where you give it your information. Like, here's my email and password and name and blah, blah, blah. And it will add you to the database and say, hey, welcome, you've signed up. But then it'll also be like, and here's, hey, here's a, what just pinged at me? Sorry, one second. Oh, it's just a message. Yeah, so I mean, an API is often for, it'll like receive data and decide where to put that in the database. It's the example I was just giving though is like when you sign up, it might send an email to you. So it'll connect with an email service that will send an email, and it might text you at that same moment. So it'll connect to a text messaging service and text you. And then it might need to set up payment for you or something like that. So it might set up like a Stripe account or something like that. So whatever the business needs are of wherever you're working, like a lot of that logic, a lot of just the processes of the business are going to be either in the server themselves or at least sort of like strung together where the server is then sort of communicating with other stuff to kick off certain jobs or to like run different things based off what's happening. So the server is like, and the database are often what are called the back end of an application. So it's not directly what you're seeing as the user. You're seeing the front end, which is either the web app or the mobile app or the iPad app. And those things are communicating with the server. And then that thing is like this massive, that's where like a ton of the code is, right? So when you think about using Uber or Postmates or whatever, you have the front end and you say, you know, give me food, but then it is going to do all this. Server is going to kick off all these processes when you do that, which is like text them and then like watch this thing and see if it takes more than 30 minutes. And if it takes more than 30 minutes, like maybe something's jacked up. And then like message the driver and then make sure the driver said yes. And then if the driver said yes, like we got to pay that driver. You know, so like all that logic, all that back-end processing stuff is happening in the server. And so there's just a bunch of code hanging out on the back end doing all this stuff. So we're going to be in this module mainly learning about, hey, how do you use a database? Like, how do you put data in it? How do you get data out of it? And then how do you write code that responds to particular URLs? So like if someone makes a GET request to a server that I'm writing, which we'll talk about the difference between what the different types of requests are. But if someone makes a request, like how do you write the code to actually respond to it? How do you respond with JSON data to somebody? And so that's kind of the main scope of what we'll be doing for this module. Okay, so now I'm going to jump into what kind of makes up a request and what the different types of requests are. Any questions before we start doing that? Okay. I'm going to close this beautiful Jamboard. Okay, so there is this dummy JSON.com website. And if you scroll down on it, there's just a few different URLs that will give you back data when you request, and it's just when you make a request to them, and it's just fake data. So I want to show you guys some of the different things here. So let me zoom in a little bit. So whenever you make a request in just like Chrome or whatever browser you use, oh, you're not seeing this, sorry. Okay. Okay, so whenever you're making a request, just a normal request, like when you type in a URL and you hit enter, that is always a GET request. So that's literally this right here, this verb, get, all caps, GET. So that's one type of request that you can do with HTTP, is a GET request, which just means, hey, I want data. Just give me back some data. And that's like almost always what you do. Whenever you do that, it's always to a particular URL. It's always to a particular host name and then a particular path. So we learned about and coded a little bit with URLs on the front end. Like when we were doing our React app, we were like, how do we make it so that when we're on a page, the page is different depending on what the URL is? And that's, you know, really important for being able to send URLs to people, and it's really important for like the bookmarks and the history in the browser. So that was all on the front end, but the exact same thing, the exact same notion of a URL is used on the back end as well. So we have our front end URLs, but then the front end often is querying data to URLs on the back end that correspond with data that you typically want to show on those pages. So like it's the same concept though. We like come up with, like we literally make it up, like what URL we want to use. So if you were making a to-do app, and you wanted to get all the to-dos that were in the database associated with your user, the URL would potentially be like /todos /user ID /1 or something, which would be like your user ID. Or potentially if you have like a token, which usually we're like logged in and there's a token that's identifying us, then we wouldn't need that in the URL. The URL could just be /todos. So I'm just deciding, hey, in my app, I want to use the /todos URL to give back to-dos. And that's fine. We just sort of decide what URL we want to do based off kind of what makes sense. Now there's a whole like field you can learn about called RESTful APIs or REST APIs, which is like the convention around how you should go about deciding what URL to pick. But like, it's really kind of pretty intuitive. Like, it's not like you can, whenever you're like, hey, this is the, like if you're making like a Medium copycat or something like that, which is what we're going to do in this class. So you're going to have like a blogging site, like author, like /author /posts or like /post ID /comments, like is the URL that would give you the comments for a particular post. Like it'll all be pretty intuitive when you see it. So you can see kind of an example of just some fake data following that paradigm here. So get /products will get all the products for you, and get /products/1, which is, that's a route parameter. So like you're supposed to put in like the ID of which post you want or which product you want. So this is saying, get me the product with the ID 1. So get a single product. That's not saying, well, I don't think that's the limit by 1. I think that's like the ID. At least that's what most people would do. And then you can see if you wanted to search by products, so you don't want all products, you want to search by products, you may use a query string like this with /search on products. And these are all GET requests. So all of these are getting data. But that's not all we do on the internet, right? So when you sign up for a site, you're signing up for Facebook, you are sending them information that you want them to add to their database. And that we don't use a GET request for. We use what's called a POST request. So you can see here's a different verb than GET, which is POST. And that means, hey, I want you to create data. Like this is brand new data you haven't seen before. I'm a brand new user. I've never used Facebook before. And so you would post your information there. And that would be like, I don't know what URL they would use for that. It might be like, you know, /signup/new user, and then you post your data. But for this dummy JSON API, they're using, if you're wanting to add a new product, it's /product/add. So you post to that URL and give it the data that you want to create. So we've seen get data, create data. You can also update data. So imagine, you know, you are working on a Medium article. It's a blog post. You put it out there. You created it. So you posted the body of the article, and then you realize there was a typo in it. And so you want to fix the typo and update it. There's actually a separate HTTP verb for that, which is put. And in that case, you have already created something. And so we would have the ID for it at that point. So you'd have some sort of identifier for that particular blog post. And so you would do, you know, /products/1 for the ID and give it the information you want to update with. And then finally, I'm sorry, I'm like switching between examples here, but most people want to delete their Facebook, so I want to switch back to Facebook. There's also a delete verb, which is, hey, I want to get rid of my Facebook account. My ID for my Facebook account is 50 or whatever it is. So I'm going to do delete and pass you the ID and the URL of my Facebook account for you to delete. And you know, Facebook would pick whatever URL they want to use for that. The reason that we can just pick what URLs we want is because you're writing your API and then you're also writing your front end. So as long as you coordinate, like as long as what you pick on the API is what you then use on the front end, like that's what matters, is that we just know what the routes are, and you want them to be clean and make sense. And so we have different standards that we follow. Just because when someone's looking at an API, you know, they want to use what they're used to, but you get to pick what you want, because ultimately you're either telling a front-end developer, here's what the URLs are, or you are a full stack developer and you're writing the backend and the front end at the same time, and you're just coordinating your work to use that URL that you're creating. So all that to say, there's a bunch of different verbs besides the ones that we just talked about, but there's 4 main ones which correspond with, I mean, it is unfortunate that we don't use the same verbs, but there's an acronym in databases called CRUD, CRUD, which stands for create, retrieve, update, and delete. So every database can do those 4 things, which makes sense. Like you create data for the first time, update it if it already existed, retrieve it because you're putting it in there so that you can get it back at some point, right? And then also delete it. You want to be able to delete it. So CRUD is those 4 verbs. They correspond to HTTP verbs, which are what would be the verb we would use in HTTP for the create part. Does anybody know?
Post.
Post, good, very good. And then retrieve,
Get.
yep. And update, put. And then the final one's pretty easy. It's the only one that matches. So delete is the same verb in both. So yeah, there's an app that I'll have you guys download for the next class called Postman. So I'm going to pull that up here. And when we're using our browser, we go to a URL. And like I said, like whenever you go to a URL, you're always doing a GET request. And there's no way for you to like manually in Chrome kick off a post request or a delete request. Now you certainly make them, but the front end that you're using is doing them for you. So like when you hit submit on a form, it's doing a post request, but you're not like directly initiating that. The front end is doing it for you. So if you want to directly initiate a post request or a put request or a delete request to an API that you're trying to learn how to use, that you may need to integrate with or something like that, a lot of people use Postman, and it's just an app that allows you to put a URL and then set like every other HTTP parameter that your heart may desire. So if you're looking at this, my screen here, if it's big enough, I've got like a tab. You can have more than one tab for different requests you want to send. And I get this drop down right here, and I get all the different verbs. Now keep in mind, I have not used more than half of these. Like I've never used lock or unlock or purge or whatever these are. I only use typically get, post, put, and delete. So those are the only ones we're worried about, and those are the only ones I ever use, to be honest. So this drop down allows us to pick, hey, what type of HTTP request do we want to make? So you can make to the same URL any type of request that you want. So like we can have a route that is for the same URL that our server, depending on whether it's a GET or a POST, will do different things. But we can say, hey, let's make a POST request. And remember when we were looking at the site here, they had, well, let's start with a GET request, just so you guys can see that. So they're saying, hey, if you want to make a GET request, here's the URL. So I'm going to copy the URL, and it's going to get you all the products that we have. And this is just fake data. But I'm going to put that URL. Oh, it didn't actually copy the whole thing. Copy the link address. Yeah. All right. So here's the URL, https dummyjson.com/products. And then we want to make a GET request to that. So I'm setting that. And then I'm going to send that. And you can see the response down here is JSON. So it's giving back an object with a products key that then has these properties. So it's an iPhone 9. And then there's an iPhone X, and a Samsung, and an Oppo F19. Anyway, so just data that we could potentially display on a front end if we wanted to, using the same style we did with the weather API. Like, we're going to make a front end that's going to show certain things in a card or whatever, and we pull out the properties we want to show in the front end. So that's what this route does, is a GET request to get those products. But that's not always what we're trying to do on an app. Like, sometimes we're trying to, like, if we're doing a blogging application, we want to add a new blog. Or let's say we are doing a product application, because that's what this dummy API is giving us. We need to add a new product that's coming out or something like that. For that, we would use a different URL. We would use, as you guys mentioned before, a post request. And does anybody remember what the URL was for that? So it's products what?
Add.
Say that again?
Add.
Yeah, /add. And okay, so at this point, you're all probably like, okay, well, like, we changed the URL, we said post, but like, how do we like give it the data that we want to send it? So whenever you make an HTTP request, there's actually a few different parts to the HTTP request. There's the URL we want to do, then there's the verb, the type of request we want to make. Then there's headers. So you guys have maybe heard that term before, but there's also typically headers that you would include in a request that are sort of like metadata about the request. And it's typically stuff like, I want JSON back, like I'll accept JSON, like, so like content type is a comment header. And then also typically we have like our token that identifies us as a user in the header. So whenever you sign in to a site and you give it username and password, it will typically give you back a token. And then you just send that token in the header of every request you make after that. And so it knows who you are. So there's the headers. And you can actually see here, like, I have a slot that says headers, and I can set key value pairs. Sorry, it's a little hard to see. For whatever I might need to do in the header. There's actually, Postman is auto adding certain headers that it's hiding. And so you can see it's just saying like, hey, here's who I am, like just telling it who it is. It's like, hey, I'm Postman, the user agent. Often you'll see like user agent Chrome or Firefox or something like that sometimes. And then it's also saying, hey, like, I'll accept any type of data. And also if you want to, you can zip it, like you can compress it if you want to, and I'll uncompress it. So like just a bunch of stuff that you don't need to worry about quite yet. But the headers are often included in every request, which is sort of like some metadata about the request. But more importantly, why I was bringing this up is there's a body that you can send. So URL, type of request, headers, and then body. And we never have a body typically in a GET request, because the only thing you need is the URL for that. But for a post request, we're saying, hey, we want to create data. We want you to create something. I want you to create a new blog post, or I want you to create a new user. And so we will typically pass a body in a post request, which is the data that we wanted to add to the database. And we always typically send in the body a JSON payload. So we just, if we were wanting to make a new article on our Medium post, we might have on the front end, we might end up having like an object with like author, date, title, and body of the post. And what we would do is we'd say, hey, we're going to make a new post. So we'll make a new blog post. So we'll make a post request to this URL in our API. And then I'll turn that object into a JSON payload and put it in the body of the post request and send that over. And so you can see we can set, whenever we're doing our products, we can set the body here. And I was playing around with this earlier, so that's why this is already here. But typically what we'll do is, you can see I chose raw and then JSON. So there's like different formats you can use for the body, though typically you're gonna do JSON. And then you can see I'm just putting in sample data here. So this is a fake API, so it's gonna let me put whatever data I want in here. But normally you would have to put it in a very particular format that API is expecting. But yeah, let's just say I wanted to add a new product. And so that product would be iPhone 14. And its price is 300. And the description is, we did it again, you know, and this might be whatever we typed in to add a new product. And so it's going to go into the body. So the components of this, we're doing a post request to this URL, and then here's the data that we want to send. And so we can send this and see what it gives back. And what it gives back, so here's my request at the top half here, what I sent, and on the bottom half is what it responded with. And the response is often very similar in terms of what content you can have as the request. So we have a body in the response, and a GET request also has a body. Like we've seen that before. Whenever we make a GET request, we get back data, we get back JSON. So that's been the body the whole time. So we've seen that before. In this post request, we also get back the body. And notice it's just sort of spitting back the data I sent it, because it's a good little fake API. So it just gave me back what I sent it. But notice it gave me back an ID. And so that's how, like, whenever you're posting data for the first time, if it's brand new data, it doesn't have an ID yet. So whenever you do it successfully, it gives you back an ID so that you could use that to update it if you needed to. So the front end then knows about that ID so that it can make a put request and pass that ID to update it if it needed to. IDs are often either numbers that just keep getting bigger and bigger and bigger, or more often these days, like a string that's just got a bunch of junk looking text in it. All right, so we get our body back. It responds with headers. So it's saying like, hey, here's all this stuff you might be interested in. And usually you don't care about these headers. It's saying, hey, I'm sending you back JSON. And hey, here's how long it is, 94 bytes. So anyways, that's there. The header's there, which is just like a key value pair, a bunch of different key value pairs. And then more importantly, what you haven't, I don't know if we've talked about too much, is the status. So you're always going to typically care about the status. And there's a bunch of different status codes that you guys have all heard, I'm sure. 200 OK just means, hey, everything went exactly as planned. And here's what you wanted. Here's the data back. So we usually have a status code and a status text. The status code is 200. The status text is OK. Does anybody know another status code?
404.
404 means, hey, I don't know what you were looking for because I never added any logic to handle the route that you asked for. So 404 should mean a little bit more to you guys, which is like if you just type in either, like if you make the wrong type of request to a URL, like, so I made a GET request to the URL we just used, and it said 404 not found, because there's nothing, like, because they're listening to it for a post request at that URL, not a GET request. So you'll get a 404 not found for that. or if I just make, a GET request or whatever to just like a junk URL that they've never seen before, or like they didn't code their server to listen to, you'll also get a 404 for that. Does anybody know any other status codes? 500? 500 means like that was not planned that happened. Like you requested something and it's our fault. Like our server just like threw up for some reason. And normally there's errors you'll get that are, it's your fault, not the server's fault. So there's like 200 response. Yeah, great, Amanda. So anything in the 400 range is like you messed up. 500 is like, shit, we messed up. 200, hey, everything went great. And I don't know if there's anything I don't know if there's any 300 codes. I assume there is. But those are typically the ones you'll see. So you'll typically see like 200, 500, 401 is very common, which means you're not authorized to do this. So 401 unauthorized, like you don't have the right token, or you don't have the right permissions or the right role. There's also like 403 bad content, like you tried to send it data that wasn't in the right format, stuff like that. So the status codes, again, like there's so many, but you're typically only going to be dealing with a few. Just like with the verbs, like there's so many verbs, but we're only going to really deal with get, post, put, and delete. So anyways, yeah, that's kind of the main stuff you all need to know in terms of like the anatomy of an HTTP request and the different types of HTTP requests you can do. And so what we're gonna do with the rest of the time we have is I'm just gonna show you guys really quickly, like how you, and like we're gonna use so just like how we did document.get element by ID a bunch early in our days to update the HTML dynamically. And then we were like, hey, like, by the way, there's React and that's way better. And that's how everybody does it now. Like, I'm going to show you guys the like raw old way that you may write an HTTP server, but you're not ever even going to have to do it because literally nobody does it. And everybody uses a framework to make HTTP servers. And we're going to use a framework called Express that Braden's going to be showing you guys on Saturday that makes it really easy to write HTTP servers. But I'm going to show you guys real quick just like what it looks like to write one and respond to an HTTP request. So, hey, Braden, will you actually put that in Slack just so they have it after class? So yeah, that's what a server is. Like, we're just gonna say, hey, if someone hits this URL and they're making a GET request, here's what I want to do. I want to give them this back. And if someone makes a post request to this URL, then I want to run this code and give them this data back or whatever. So that's all you're doing when you're writing an HTTP server. So let me show you guys that real quick. 418. So like I think Twitter, somebody made 420 status. So yeah, you can have fun looking up all the different statuses that are out there. Okay. So okay, so we're gonna write our servers with Node. So Hannah, like you were right in some sense with what you said about Node. So we're just gonna write a JavaScript file. We're just gonna make a JavaScript file, and then we're gonna run that file with Node, and it's gonna just keep running. Like we're gonna set it up so that it's a server, so that it doesn't like you don't run it and then it just stops. it'll just like keep running until we tell it to stop running. So that's the one difference between like a normal node script that you would write, where you would run it and it would exit at some point because it got to the end of your code. When we write a server, it's going to evaluate the code, but then endlessly listen to the internet and just wait for a request that it can respond to. But that's like, we're just going to run a JavaScript file with Node to make a server. That's literally it. So let me make a JavaScript file. So I'm gonna, well, I guess I would normally do this in VS Code. So I'm gonna open VS Code. And I'm in day 1 of module 5. I'm going to make a server.js file. So here's my JavaScript file. And then now I got to write my HTTP server. So I'm going to have to look that up because I always use Express. I want to go to okay. So I'm going to copy this code and then I'll explain it to you. So this is stuff that you guys will read before Saturday, this article, but I'm going to show you guys this real quick. Okay. So here's all the code for server that is going to respond to one URL, just the root URL. Okay. So normally when you write a server, you're going to have it do like respond to a bunch of different URLs depending on what your app does. But we're just going to make it respond to one URL to start. And Node, like just like in the browser, we like whenever we're running a script in the browser, we had access to the document API where we could update the page. When you run a JavaScript file in Node, you have access to various different Node APIs. And one of those APIs is called HTTP. And it's an API you use if you want to do something with HTTP. And the thing we want to do is listen for requests, HTTP requests. So we're going to pull in, and I know, like, so unfortunately Node and then like modern front-end JavaScript like have different import and export styles by default. So like when we were doing React, you guys we're doing like import blank from the file name. And this right here you're seeing is like back to that old style, which was like const something equals require from a file or from a module, built-in module. We're actually going to set it up whenever you guys are writing Express so that you can do just the normal import style that we did for React. But like just for this example, just note that that's why we're back to require. But that's just for this example, not for the rest of the class. So we're pulling in this Node built-in API. And notice I'm using API in a different context. That may be confusing you. And I mentioned like people say API for all these different things. So I'm not talking about like a REST server API. I'm talking about an API that like allows me to do certain functionality. And programmers just use that term that way. So API just means application programming interface. It's a very generic term. But yeah, so I'm using it in the sense of like, here's something that's going to give me a way to talk with the internet. It's a thing with certain methods that I can call to do a certain thing. Okay. All right. So then we just set as variables where we want to listen, what host name we want to listen on, which 127.0.0.1 is localhost. So remember, we've done localhost stuff before. Whenever we did our React app, it was always going to localhost and then a certain port. So that's what 127.0.0.1 is localhost. And then we're going to listen on port 8000. This is another thing, like pick a port. You can pick whatever port you want. People just kind of go by convention. So you'll typically see 3000 used or 5000. I mean, you'll see all kinds. And so for this example, they chose 8000. I have no idea why. I could have chosen a different port. I'll go ahead and change it just so you can see that it doesn't matter. But yeah, there's various ports you can listen on for a particular host. For a local host, we can listen on a bunch of different ports. Okay, then you can see here we use HTTP, what we pulled in, the API that we pulled in, and we say I want to create a server. So we're calling a method on HTTP called create server, and it takes this callback function. So create server is a function that takes a function, and that function then receives the request, the HTTP request, and then we then gain access to a thing called the response, and then we sort of dictate what we want to do for the response. And so this block here of code is saying, I want to make a server, and then whenever a request comes in, call this function and give me the request. And then based off the request, I'll decide what response I want to do. So that's all we've done here. And you can notice it's saying, okay, well, if we do get a request, it doesn't actually look at the request. It just, it doesn't care what kind of request it is or anything like that. It's just going to respond with a 200 status with a header of content type text plain. So it's not responding with JSON, it's responding with plain text. And then it's here, and then it's writing the body here. So it's sending it's response.end, and here's what I want to send back. And so like just respond now. So this is saying if someone makes a request to our server on localhost port 5000, no matter what URL, no matter what type of request, send them back a 200 OK status with a header of content type plain text, and then give them this plain text that says hello world. So that's what this is saying, this logic here. And then, so we made the server, but we haven't ran the server yet. And so that's what this line is. It says, okay, it says, take our server that we just made, listen on the port that I set up here and the host name that I set up here. And then if it successfully starts and starts running, then call this function and just let me know. So I'm going to console log that it's working. And then it'll just like loop. So I'm just going to run this real quick. And like I said, nothing magic about this. It's just node and the file. So node server.js. You can see I got that console log, which is the server is running at this location. And then you can see it didn't exit. It's just running. Like if I hit enter, like it's just running right now. So I didn't get back access to my terminal to type another command. It's just constantly looping and waiting for a request. And it will do that as forever until I shut it down. Which if you think about it, like anything you talk to on the internet, like when you go to a website, something is somewhere waiting, just constantly running. And that's literally like someone literally out of servers, like ran a JavaScript file that made a server and it's just running there. And then they hooked it up to the internet so that whenever like it's literally what's happening. So we can go to our browser and go to localhost 5000 and it didn't work. Well, let me see why. Oh, did it? Let me try. Okay, I don't know why localhost wasn't working. That's kind of weird. I'm gonna have to look up why that didn't work. There might just be some sort of configuration thing I have to do for the server. But notice I did 127.0.0.1, which is like the loop back address to talk to the server running on this computer. And notice that we're getting hello world. So like on the network tab, you can see here's my request to 127.0.0.1. I got a status. So my method was get. I got a status code of 200 OK. The response header had text plain in the content type. And then the response was this text, hello world. So that, yeah, like that's it. We just did it. So normally when it gets more complicated, and what we do is we say, hey, if the request is this URL, then run this code. But that's it. Like it's literally just, hey, what is the URL? And then I'm going to map that URL of the request to some particular function that's going to run, that's going to handle the request and respond with what makes sense. And typically we're always responding with JSON. We usually don't respond with text. But we do respond with text if it's like HTML, right? Like you may respond with a big thing of HTML. But when we're writing our own APIs, now in modern days, we do React or Angular or Vue front ends that do all the HTML and stuff, and then those talk with APIs that just respond with data, just JSON data. And so that's what we'll be writing is a server, a backend server that is purely just responding with JSON data. So every single one of our responses will be JSON. So yeah, that's it as a server. What do you guys think? Pretty cool, right? So it's still running. Like I can go talk to it again. It says hello world again to me. And then if I shut it down, you know, if I stop it and then I try to talk to it again, then I don't get a response. And yeah, that's it. So any questions? Oh yeah, okay. Let me run it again. So we have been using, so I started the server again, so it's listening again, and we can do our requests. I wonder if localhost will work. Yeah, no, that's not working. I don't know why that's so weird. So yeah, I can make the same request with Postman. And you can see the response down here, hello world, and status 200 OK. And it took 16 milliseconds. Oh, shit. Sorry. Could you guys, when did I stop doing that?
Just a second ago.
Okay, good. All right. All right, so here I did the same sort of request in Postman. Instead of the dummy API that's deployed and hooked up to the internet, we're doing a server that's running on our local computer, and I make that request. can see we get back hello world, status 200. Okay. Cool. All right. No questions? Cool. All right. There's some pre-work for Saturday. I'll send a message in Slack about it now. But like we'll still follow the same format where there's that document that has all the outside work class schedule stuff for you guys. I just hadn't sent it out to you guys before this class. Which I kind of wanted you guys to have a break anyways, since it was a shorter break this time. But yeah, I'll send that in Slack and it'll be in that regular page on GitHub, and see you guys Saturday.
Sweet. Thank you.
Thank you.